Assalamu alaikum. I am your host Muhammad Shiraz. Welcome to the program Computer Programming Concepts. This is program number 23. Dear students, in earlier programs you studied in detail about pointer mechanism. You studied that pointer is a mechanism to access memory location indirectly. For that purpose, we need to declare a pointer variable, initialize a pointer variable to the memory address of a variable, and then you can access the value of a memory location indirectly by using pointer mechanism. You also studied that we can access the elements of array by using pointer mechanism. In today's program, we will study how to implement the pointer mechanism in function. You will also study an advanced concept of pointer, that is indirect pointer. Let's start today's discussion. In earlier programs, you studied that when a function is called, you may pass some value to that function. In those examples, when the value is passed to the function, then value is passed by value. It means that the value passed at the calling function is copied to the called function. You can use pointer in the function calling mechanism as well. Pointer mechanism turns out very helpful in parameter passing and returning value from a function, because you studied earlier that a function can return a single value at a time. A function may have more than one return statement in its body, but a single return statement is executed at a time. When you want to return more than one values from a function, then you may deploy pointer mechanism in that case. So let's study how to implement pointer mechanism in function, in passing value to a function and returning value from a function. Pointers are passed by value. The value of pointer variable is the address it holds. If the value of the target variable is changed through the pointer, change will be reflected to the actual variable holding that value. If we change the pointer variable itself, the caller would not see the change. Let's study an example. This is a swap example. The function is declared with the name swap. Return type of the function is void, which means the function will not use any return statement inside its body. The function is declared with two integer parameters, and they are basically pointer variables, which means when the function is called, we will have to pass the memory addresses of two integer variables. This is the function definition statement. It resembles to the function declaration statement. Now let's come toward function calling. Now here, when we call swap function, we will have to pass the memory addresses of two integer variables. For this purpose, we have declared two integer variables. Carefully observe that here a is initialized to the value 8 and b is initialized to the value 10. Then the swap function is called, and while calling the function we have passed the address of variable a. Thus the address of variable a will be copied to the pointer variable x. Similarly, the address of variable b will be copied to the pointer variable y. When the function swap is called, now x and y have got access to the two variables a and b. Now inside the body of swap function, we can access the value stored at the address held by x and y. Now inside the body, we have declared another variable temp. Temp is initialized to static x, and we know that static x is currently pointing a. That is why temp will be initialized to the value of a, that is 8. Then static x equals to static y. Now the value of x will become the value of y, that is y is pointing b. That's why static x will become 10, and then static y is initialized to the value tmp, and the value of temp is 8. So static y, that is b, will be changed to 8. Then control will return without returning any value formally. But you should notice that here inside the swap function, we have accessed the memory location of the two variables a and b, and inside that function we have changed the value of those variables indirectly as well. That's why when control return from the swap function, now inside the main function we are displaying the current values of a and b. That's why a equals to %d and b equals to %d. Now a will be displayed as 10 and b will be displayed as 8. Let us exercise this program on the computer screen. You should see in this example that we have declared a swap function. The function is called with the address of a and b. These addresses are copied to the pointer variable static x and y, and inside the body of swap, the pointer variables are accessing the values of the variable a and b indirectly. Not only pointer variable is accessing the value of the variable a and y is accessing the value of variable b, but instead these variables are also changing the values of those variables as well. Let us see the output of this program. Again, I will repeat that we have initialized a to 8 and b to 10, and we have not changed the values of these variables directly by using the names of these variables. But now see in the output that the value of a is 10 and the value of b is 8. It is because inside the swap function, the pointer mechanism is used to access the values of these variables indirectly, and pointer mechanism is changing the value of these variables as well. Dear students, this was about how to implement pointer mechanism in language C. In this mechanism, you simply initialize a pointer variable to the memory address of another variable, and then by using pointer variable, the value of that memory location can be accessed by using static operator. There is a more advanced concept of pointer as well, that is called pointer to pointer. Let us study briefly about pointer to pointer. A pointer variable can itself be pointed by another pointer variable. This mechanism in which a pointer variable by itself is called by another pointer variable is called point to pointer or double indirect pointer. Let's study an example. Through this example, I want to explain that we have declared a pointer variable static x, and you see that x is declared with a simple static operator. This is called a single pointer variable or a simple pointer variable. Then there is a simple variable y. This is a variable of integer data type. And then there is another pointer variable z that is declared with to static. This pointer variable is called pointer to pointer variable. This variable means that this variable is of type integer, which means that this pointer variable will contain memory address of an integer pointer variable. Now we have initialized y to 50, then x simple pointer variable is initialized to the address of y, and in the following statement pointer to pointer variable z is initialized to $x, which means that the address of the pointer variable x is assigned to the indirect pointer variable or double indirect pointer variable z. You should remember that a simple pointer variable is initialized to the memory address of a specific value or variable. The value of a pointer variable can be the address of another variable of the same type, but in indirect pointer the value of a pointer to pointer variable can be the address of a simple pointer variable. You cannot initialize a pointer to pointer variable to the address of a simple variable. I'll explain this concept through an example. Now here x is a simple pointer variable, that is why it is possible to initialize z to the address of x. Now let's see, this printf statement will display value of y and then address of y. By this statement it will become clear to us that how the value of y is accessed and how the address of y is accessed directly. Then this statement will display the value of x, that is basically the value of x is the address of a variable, that is why we will have to use %u. So value equals to %u, this will display the value of x, which is basically the address of y, and then address of x by itself will be returned by $x. Then the statement at line number 8, value at static x, and that is basically the value of y, that's why we use %d. So static x will return the value at address held by x. And there are two additional statements. This printf statement will return value of z, and we know the value of z is basically address of x, that is a pointer variable, that's why we use %u. So value equals to %u will return the value of z, that is the address of x, and then address of z by itself will be displayed by this $z, and we use the format specified %u. And then an interesting point, how to access the value indirectly. When we access the value of y indirectly through z, then we will have to use double static operator. That's why the statement at line number 10, value at static z is %d. So it is very simple, static z will give access to us up to the value of x, and we know the value of x by itself is the address of y. Therefore, the next static will give us access to the value stored at x. Let us exercise this concept through an example. This is the same example. We have declared a simple pointer variable x, a pointer to pointer variable z, and then we have initialized y to the initial value 50. Then we initialize x to the address of y, then z to the address of x. I should again repeat that z is a pointer to pointer variable, and the value of pointer to pointer variable can be the address of a pointer variable only. And then this statement will display the value of y and address of y. This statement will display the value of x, that is address of y and address of x. This statement will display the value at address held by x. This statement will display the value of z, that is basically address of x, and ampersand z will return the address of z by itself, and this statement will return the value at address held by z, and then the value at address held by that address. That basically points y, which means static z will give us access to the value of x, and then static x will give us access to the value of y. Let us execute this program. You see in the output, this is the value of y, this is the address of y. This is the value of x, that is basically the address of y, and this is the address of x by itself. This is the value at static x, means the value at address held by x, that is 50. Then the value of z, that is basically the address of x, and then the address of z by itself, and we know that z is pointing a simple pointer x and x is pointing y. That is why static z will give us access to the value of y indirectly. That's why static z is displaying the value of y, that is 50. Let's make some changes in this example. We can change the value of y indirectly through double indirect pointer as well. Let's execute this program. Now you see that initially the value of y is 50, the address of y is this, then the value of x is this and address of x by itself is this, and then the value at static x is 50. Then we used indirect pointer, value of z is this and address of z by itself is this, and then we accessed the value of y indirectly by using double indirect pointer. That's why value at static z is 50. Then we have changed the value of y double indirectly by using double indirect pointer. Static z equals to static z plus 15. That changed the value of y to 65. Therefore, value of y is 65. When we access the value of y through the simple pointer, value at static x is 65 and value at static z is 65. So dear students, it concludes a discussion about pointer. I hope you might have got a concept about simple pointer and indirect pointer. It ends the time of our today's program. See you next time. Allah Hafiz.